Number 5 from your second proof worksheet. And the reason I have a line down the middle is I'm going to show you 2 ways to do this. So again, remember you have to choose a side to start from. My general rule was choose the more complicated side. So I'm going to show you that way first, but then I am going to show you how to do it from the left to the right. So first we are going to write what we had. Plus this. And then I have my cosine of x. Okay, what you need to notice when we do here, this is technically a quadratic in disguise because I could rewrite this as sine squared x squared minus, that's a minus, 2 sine squared x minus plus 1. And then all of that times cosine of x. So this is a quadratic in disguise. If you can't see that, one way I can show you, and I'll use blue pen to show this, is if I let y equal sine squared of x, I get 1 minus 2y plus y squared because y is sine squared of x. So that's just showing you it's a quadratic in disguise. So because it's a quadratic in disguise, I can then factor to get here. I need something that multiplies up to 1 but adds up to negative 2. So then again, my variable though is sine squared. So I'm going to get sine squared x, set up my parentheses, sine squared x, and then I still have this cosine of x chilling out here. So again, I need something that multiplies up to positive 1 but adds up to negative 2. Well, that's negative 1 and negative 1. So I just factored that. It was a quadratic in disguise. It's kind of hard to see, but that's all that was. Then, a huge hint should be going through your head. You have something squared here. So look for your trig identities. Okay? Again, your main trig identity is sine squared plus cosine squared equals 1. So I know sine squared x minus 1, after I manipulate that formula a little bit, I know this is equal to cosine squared x, which means this is also equal to cosine squared x. And I had a cosine x to begin with, so that's just chilling for the ride. Well, now I have 2 of them here, and 1 here, so I have a total of cosine to the 5th x. That's one way to do it. Proof done. The main thing you had to see when you did this way is that that was a quadratic in disguise. Now, if you go back and want to start with the cosine to the 5th x, the only thing we can really do is wish, okay, we know we're going to need them in terms of sine. Well, cosine to the 5th is nothing, I know. But I do know what cosine squared is. So I could rewrite this as cosine squared x, cosine squared x, because that would give me cosine to the 4th, cosine to the x. The reason this is helpful, I know what cosine squared is. I don't know what cosine to the 5th is, but I know what cosine squared is. So I'm just rewriting them. These are all technically times each other. Then the fact is, I know what this is. This I can rewrite as 1 minus, or sine squared minus 1. And again, that comes from the sine squared x plus cosine squared x equals 1. To get cosine by itself, I'd subtract sine over it. So that means I could also rewrite this one as sine squared x minus 1. And then I just know cosine of x, that's just cosine of x. Then, gotta just FOIL them out. So, sine squared times sine squared is sine to the 4th. Then I get minus sine squared minus sine squared. Negative and negative make plus 1. So I FOILed that, and then I still have this cosine x outside. Then I just simplify. I got 2 of these. And then plus 1. And then I got to where I needed to be. So that would be the end of that proof. So again, you can choose where to start from. In all honesty, I think this way is easier to start from, which kind of broke my general rule. But if you find yourself getting stuck here, you can try it this way. And that's only when I have something higher than to the second power, like cosine to the third, cosine to the fifth, cosine to the fourth, cosine to the 10th. I could do stuff like that. But if you can see that this is a quadratic in disguise, you could factor it and go this way. Otherwise, you could just break down cosine to the fifth as cosine squared, cosine, and go from there, and then use your trig identities. So again, two different ways to do the same proof, and you're done.